Assalamu alaikum everyone. Welcome to the course of ME212 Dynamics. This is lecture 28. So in this lecture we will study about the relative motion analysis and derive the acceleration equation for the general plane motion. In the previous lecture we derived the velocity equation for the general plane motion and solve numerical. Similarly in this lecture we derive the acceleration equation for general plane motion and solve some numerical related to the general plane motion. So the velocity equation that we derived in the previous lecture was VB equal to VA plus VB with respect to A, where VB is the velocity of the particle B, VA is the velocity of the particle A, and VB with respect to A is the velocity of the particle B with respect to A. This is the equation that we derived in the previous lecture. So this was because of the translation. This was because of the rotation. So VB was because of the translation plus rotation. So VB contained the effect of both translation and rotation, while VA contained the effect of only translation motion, and VB with respect to A contained the effect of rotation motion. This is the equation that we derived in the previous lecture. So how can we further write this equation? So VB equal to VA. These both are the absolute velocity, while VB with respect to A was the relative velocity, and that was caused by the relative displacement. So the equation further we write was omega cross R B with respect to A, because this was because of the rotation, and the rotation in the rotation motion the velocity was equal to omega cross R B with respect to A. This is the equation for the velocity. So how can we determine the acceleration? We have to take the time derivative of this equation. So by taking a time derivative, d by dt of Vb equal to d by dt of Va plus d by dt of omega cross Rb with respect to A. So what is time derivative of Vb with respect to A? Is the particle velocity, particle B velocity is measured with respect to the fixed inertial frame of reference. So this means that it is our absolute acceleration AB. Time derivative of the absolute velocity become absolute acceleration. Similarly, the particle A displacement position, the particle A velocity, and the particle A acceleration will be measured with respect to the fixed inertial frame of the reference. So it will be also become equal to A. While this is basically, this term is because of the relative displacement are because of the translating axis. So here in the time derivative we have omega and Rb with respect to A. So we have to apply the product rule. So by applying the product rule, what we get? D by dt of omega cross Rb with respect to A plus omega cross d by dt of Rb with respect to A. Now what is omega, the time derivative of omega? Basically the time derivative of angular velocity is angular acceleration, so it become alpha, where alpha is your angular acceleration. And what is time derivative of position of the particle B with respect to A? It become Vb with respect to A, the velocity of the particle B with respect to A. So this is so the in the previous slide the acceleration equation that we tried was AB equal to AA plus there was d by dt of omega cross Rb with respect to A plus omega cross d by dt of Rb with respect to A. So this equation further become AB equal to AA plus what is d by dt of omega, rate of change of angular velocity. This is basically alpha, your angular acceleration. So alpha cross Rb with respect to A plus omega cross what is time derivative of the position of the particle B with respect to particle A. This is basically your velocity Vb with respect to A. So in the previous lecture we also write that the velocity of the particle B with respect to A is basically, what is this? This is basically omega cross RB with respect to A. So by substituting this, the equation become alpha cross RB with respect to A plus omega cross RB with respect to A. So this is the acceleration equation for the general plane motion of the rigid body. So here A is basically acceleration A and acceleration B is your absolute acceleration. Now what is this and what is this? This is basically relative acceleration. These are the acceleration of the particle B with respect to A. So what is meant by this? So how can we find out the direction of the alpha cross RB with respect to A and omega cross RB with respect to A? So these direction can be find out using right hand rule. So the rule of right hand rule is basically, in the right hand rule, if you have to find out the cross product of two vector, let's say that you have two vector A and vector B. So first vector is vector A. So point your hand in the direction of the vector A. So after pointing your hand in direction of vector A, now you are constrained that you only rotate your hand, but you can't move your hand. So when you point your hand in the direction of vector A, now point your palm in the direction of vector B. Now when you point your palm in the direction of vector B, now curl your finger in the direction of vector B, the thumb point the direction of A cross B. So if you have two vector A and B, so let us say that there is a third vector C, which is the cross product of A and B, which is the cross product of A and B. There is a vector C. So vector C has to be perpendicular to the plane containing A and B. You must keep this thing in mind that when you find out the cross product of the two vectors, then if there is a third vector which is the cross product of two vectors, then the third vector has to be perpendicular to the plane containing two vector. So this is all about the acceleration. Now the acceleration equation that we derived is AB equal to AA plus alpha cross RB with respect to A plus omega cross RB with respect to A. Now to find out the direction of alpha cross RB with respect to A and omega cross RB with respect to A. Let us say that you have a rigid body. Let us say this is the rigid body, and this rigid body has two particles. Let us say that this is the particle B and this one is the particle A. Now consider the inertia frame of the reference X and Y, and this is your fixed origin. So what will be the position of the particle A with respect to the fixed inertia frame of reference? RA show the position, particle position, and RB shows the position of the particle B with respect to A. Let us say that your translating axis is on particle A, X prime and Y prime. So what will be the position of the particle B with respect to A? You have to draw the position vector. So this is the RB with respect to A. As the rule is that your in case of relative motion, your vector should start from the observer and end at object. So this is all about generally this is the thing that we discuss in the start from the start of this chapter. So is this body, let us say that this alpha cross RB with respect to A is because of the rotation motion. So let us say that this body is rotating about the axis which is passing through the point A with an angular velocity alpha and with an angular velocity omega and angular acceleration alpha. So this means that this body is moving with an angular velocity omega and angular acceleration alpha. So according to right hand rule, curl your finger in the anti-clockwise direction. Your thumb point the direction of omega vector and direction of alpha vector. And let us say that the third direction is basically z direction, which come out from the slide. So this means that omega vector is in vector form omega equal to omega magnitude time k unit vector. Similarly alpha is equal to alpha time k unit vector. Now what is here, the term is alpha cross RB with respect to A. What is alpha? Let us say that alpha is basically coming out from the board. So on point A, the alpha will be out from the board, and RB is basically pointing from A and end at B. Now first you have to point your hand in the direction of alpha. So you have to point your hand vertically upward. Now when you point your hand vertically upward, now point your palm in the direction of RB with respect to A. Now when you palm your direction, your palm in the direction of RB with respect to A at point A, now your thumb point the or alpha cross RB with respect to A, and which will be equal to, which will be in this direction, and this will be your direction of alpha cross RB with respect to A. So at point A, this will be direction, and similarly at point B, this also become the direction of alpha cross RB with respect to A. This will be the direction at point B. So I simply rub this thing. Are you clear with direction of alpha cross RB with respect to A? Now, you must keep this thing that this alpha cross RB with respect to A has to be perpendicular to the plane of omega and RB with respect to A. That is, alpha cross RB with respect to A has to be perpendicular to plane of alpha and RB with respect to A. That is the plane containing alpha and RB with respect to A. The alpha cross RB with respect to A has to be perpendicular to that plane. In other words, it will make an angle of 90 degree. So it has to make an angle of 90 degree with the alpha and RB with respect to A. Now what is omega cross RB with respect to A direction? Now omega cross RB is basically in the same direction as we discussed this thing in the previously. When a rigid body rotate about an axis, this will be in the direction of alpha cross RB with respect to a same direction. Now consider that you have a vector omega vector which is coming out from the slide at point B. Now cross multiply this with omega cross RB with respect to A. So the cross product will be inner direction, inward. So this will be the direction, inward direction will be the direction of omega cross RB with respect to A. Now let us say that this body is rotating about the point A with an angular velocity omega and angular acceleration alpha. So what will be the trajectory of the particle B? So particle B has to be follow a circular trajectory about point A. So this means that this alpha cross RB has to be tangent to this trajectory, and omega cross RB with respect to A has to be normal to this trajectory. So if this is the trajectory followed, so in this trajectory this will be your direction of alpha cross RB with respect to A, and this inner direction will be the direction of omega cross RB with respect to A. So this means that this is your tangential acceleration and this one is normal acceleration. So in general we can write that AB equal to AA plus AT plus AN, where AT and AN is with respect to particle B with respect to particle B with respect to A, motion of the particle B with respect to particle A. So this is the acceleration for the general plane motion of the rigid body. So from this we got that if the body rotate, if the body displaces with an angular velocity, so it has both the translation motion as well as rotation motion in general plane motion. So in the acceleration we have relative terms as well as the absolute terms. So the absolute acceleration of the particle will be the absolute acceleration of another particle on that rigid body plus the relative acceleration of the first particle with respect to the second particle. So this is all about the acceleration of the rigid body in general plane motion. Now come to the problem. This is the fundamental problem 16-106 from the Hibbeler book. The statement of the problem is member AB has an angular motion as shown. Determine the velocity and acceleration of the slider block C at the instant it is shown here. So you have two members, one member is AB and other member is BC. So the member AB is connected to the slider by member BC. So you have to find out the velocity and acceleration of the particle C. So always start from the analysis from the member that has any of the particle is fixed or any of the side is fixed. So in this case A is fixed. So we can start from the member AB. So first we have to write the velocity equation for the member AB. So write the velocity equation for this member. So the velocity equation that we derived in the previous lecture was VB equal to VA plus omega AB cross RB with respect to A. This is the velocity equation that we derived in the previous lecture. So here as the member A is fixed, so its velocity become 0. Now what is omega AB? Omega AB is angular velocity and it is given that angular velocity is 4 radian per second. And the direction of angular velocity is anti-clockwise direction. So anti-clockwise direction we assume as positive. So according to anti-clockwise direction, now according to right hand rule, curl your finger in the anti-clockwise direction, your thumb will point in the direction of the omega vector. So when you curl your finger in the anti-clockwise direction, your thumb will be out from the slide. So this means that omega AB equal to 4 times K. Consider that this is your x-axis, this one is y-axis, and this one is z-axis. This is the inertial frame of reference, or this is the coordinate system that we are going to follow in this problem. Now what is RAB? Now RAB is the position of the particle B with respect to particle A. Now draw the position of the particle B with respect to the particle A. So this will be this. It will start from the particle A and end with particle B. Always start from the observer and end at object. So this will be your RB with respect to A. Now in the vector form, RB with respect to A will be simply equal to 2, and 2 is acting in the RB with respect to A is acting in the positive Y direction. So this means that RB with respect to A will be equal to 2 times J. Now what will be the velocity of the particle B? As in this equation we know all the things. So velocity of the particle B will be equal to 4K cross 2J. Now our convention is, if let us say that this is I, this is J, and this one is K. So I with J cross product equal to K, J cross product with K cross product equal to I, and K cross product with I equal to J. So this direction is taken as positive, and in this direction counterclockwise direction is taken as negative in this case. So K cross product with I with J. So K cross product with J will be equal to minus I. So this will be equal to minus 8 I meter per second. So this will be the velocity of the particle B. So the velocity of the particle B in the previous slide that we find out was minus 8 I meter per second. Now what will be the now this is for the link AB. As the velocity of the particle A is 0, and we find the velocity of the particle B, which is minus 8I. And the convention that we followed was, this was our x direction, this was our y, and this was our z direction. As the velocity of the particle B become equal to minus 8I, this means that it act in the negative x direction. So this means that this is the velocity of the particle B. Now come to the link BC. Now in the link BC, we know the velocity of the particle B, but we don't know the velocity of particle C. So we can write the velocity equation in terms of velocity of particle C. So VC equal to VB plus omega BC cross RC with respect to B. You can write omega BC or omega CB. There is no need to think whether you have to write BC or CB. But when you write position of the B with respect to C or C with respect to B, then you must clear this thing in mind. Either you are writing the equation with respect to C or with respect to B. As the equation we are writing with respect to C, so we have to write our C with respect to B. So in this case, our observer is B and our object is C. Now in the above equation, we know the velocity of the particle B, which is 8 meter minus 8 I meter per second. Now what is omega BC? So in the question, omega BC is not given. So in the vector form, we can assume the direction of omega BC. So we assume that omega BC is acting in the counterclockwise direction. Like this is the direction of omega BC we assume. So this means that omega BC become equal to omega BC time K. You can assume the direction. So this is what we assume. Now what is RC with respect to B? Now RC with respect to B is basically the position of the particle C with respect to the particle B. So you have to draw the position vector. So let us say that this is the position vector. This is RC with respect to B. That start from B and end at C. Now is in the question, this is your RC with respect to B. Now also it is given that this is 2 meter, and also it is given that this one is 0.5 meter. So you can simply resolve this into the two components. So this means that one of the component is 2 and has a value of 2, and other component has a value of 0.5. As both the components act in the negative x and negative y direction, so we can write that R C with respect to B equal to minus 0.5 I minus 2 j. These are 2 and these are minus 0. These are 0.5 and this one is 2. So now in the above equation we know all the thing. So you can write the velocity equation as Vc equal to minus 8I, which is the magnitude of which is the Vb value. And now what is omega Bc? Plus omega Bc time k vector, and it has to be cross multiplied with minus 0.5 I and minus 2 j. Now again you can follow this thing I, this one is j, and this one is k. So taking this direction is positive, and this direction is negative. So in this way Vc equal to minus 8I. What is k with I? So k with I become equal to j. So this will be equal to minus omega Bc j. Now what is k with j? K with j will equal to minus I. So minus and minus become plus. So in this way it become equal to plus 2 omega Bc I. So we can combine the I terms and j terms together. So Vc equation equal to minus 8 plus 2 omega Bc I minus omega Bc j. So as in the figure we can see that omega Vc is basically acting in this direction. This is the direction of Vc. So it has two components. So Vc is acting in this direction. It has two components. One has to be acting in this direction, and another one in this direction. And as given that we have triangle 5, 3, 4, you can use this triangle to find out the angle. So this will be equal to 3 by 5 of Vc, and this will be equal to 4 by 5 of Vc. Simply in the triangle, when you are given triangle, you can this equate the components as perpendicular over hypotenuse and base over hypotenuse. So in this way Vc become equal to minus 4 by 5 Vci minus 3 by 5 VCJ, and this will be equal to this complete term. So by equating I and j's together, we get minus 4 by 5 Vc equal to minus 8 plus 2 omega Bc, and j's term, equating j's term, minus 3 by 5 Vc equal to minus this will be minus, this will be 0.5, this will be minus 0.5, so minus 0.5 omega Bc. So in this way you can find out the value of omega Vc and Vc, as you have two equation and two unknown. So the value of Vc will be 2.5 meter per second and omega Bc will be 3 radian per second. So in this way you can find out the velocity and angular velocity for the angular velocity and the absolute velocity for the particles on the rigid body. So by writing the Vc in term of in vector form, so in the vector form Vc can be write as Vc equal to minus 4 by 5 time 2.5 I and minus 3 by 5 time 2.5 J. It is writing this in this equation. So Vc will be equal to 2I minus 1.5 J meter per second. So in this way you can find the velocity for the particles. So this is the first part for the numerical, in which you have to find out the velocity for the slider C, and in this case we find the velocity and both the absolute velocity and angular velocity for the slider C. The angular velocity is found to be 3 radian per second, while the absolute velocity will be in the vector form equal to 2I minus 1.5 J, and in the magnitude will be equal to 2.5 meter per second. So in the previous two slides we find out the velocities for the particles on the rigid body. Now the second part of the this numerical was to find out the acceleration for the slider C. So the acceleration equation that we derive in this lecture was was acceleration of the particle B equal to acceleration of the particle A plus alpha time AB cross RB with respect to A minus omega AB square R of B with respect to A. So as the same procedure will be followed, as in this case the particle A is fixed, so we can first we can solve for the link AB. So we have to write the acceleration equation for the particle B with respect to the particle A, and as the particle A is fixed, so its acceleration will be 0, so this term will be equal to 0. Now the acceleration of the particle B become alpha AB cross RB with respect to A minus omega AB square RB with respect to A. Now in this case it is given that this is 5 radian per second square. So what is this? This is basically angular acceleration. So this is basically your alpha, and as it act in the clockwise direction, and our convention was that clockwise direction the angular velocity or angular acceleration are negative. So this means that alpha AB become minus 5k radian per square second. Now what is RA and RB with respect to A? Now RB with respect to A will be the position vector starting from point A and end at point B. Now this will be your RB with respect to A, and it will be equal to 2 meter. So RB with respect to A will be equal to 2J. Convention is that this is X direction, this one is Y, and this one is Z direction. Now what is in the above equation? Alpha we know that it is equal to minus 5k, and RB with respect to A will be 2J. Now the third term is omega AP, and the omega AB it is given that it is 4 radian per second. Now it is the omega AB square, as it is not in the vector form, so we can simply write omega AB equal to 4 radian per second. So in the above equation we know all the things, so write the acceleration of the particle B. So AB will be equal to minus 5k cross product with 2j minus 4 square time 2j. Now again for this convention, this one is I, this is j, and this is k. So I cross with j equal to k, j with k equal to I, and the reverse manner is negative. So k with j equal to minus I, so minus minus will be positive, so it will be 10 I. Or for 16 to 32, and this will be minus 32 j. So this is the acceleration for the particle B. Now the second is in the link AB. We know the acceleration of the particle A, which is fixed and equal to 0. We know the acceleration for the particle B, which is 10 I minus 32 j meter per square second. Now come to the link BC. In the link BC, the acceleration of the B is known, but acceleration of the C is unknown. So we write the equation of the C in term of B. So acceleration of the particle C will be equal to acceleration of the particle B plus alpha time BC, the link, the angular velocity or angular acceleration of the link BC. This cross multiply with RC with respect to B minus omega BC square R of C with respect to B. This is the acceleration of the particle C in term of particle B. Now in this equation, the acceleration of the particle B is known. Here we find this thing. Now what is alpha BC? Now alpha BC, we have no idea about alpha BC, so we can simply assume that it is acting in counterclockwise direction. This is alpha BC. We simply assume. So assume that alpha BC in vector form will be equal to alpha BC in term of k. So we assume this. Simply assume. Now what is RC with respect to B? So RC with respect to B, we find out this in finding the velocity. So RC with respect to B will be acting in this direction. This is the direction of RC with respect to B. So we find out this thing previously, that RC with respect to B will be minus 0.5 I minus 2 J. So this was RC with respect to B. Now what is omega BC? So we also find out this omega BC in the previous when finding the velocity for the slider C, and we find out that omega BC was equal to 3 radian per second. So by putting the value in the above equation, we can find out the acceleration for the particle C. So by putting the values in the acceleration equation, the acceleration equation become AC equal to 10I minus 32J, which was the value of the AB, plus alpha BC K cross minus 0.5 I minus 2 J minus 3 square, which is the value of the omega BC, cross minus 0 time minus 0.5 I minus 2 J. This is the acceleration equation, and after solving we get 10 I minus 32 J minus 0.5 alpha CB. So K cross with I equal to, what is K cross with I? This will be J. So this will simply become J. Now what is K cross J will be minus I, and minus minus will become positive. So this will be plus 2 alpha BC or CB, same thing, CB I. What is 3 3 9 and 9.5 4.5 plus 4.5 I and plus 18 J. So after combining the I and J term together, so AC will be 10 plus 2 alpha CB plus 4.5 I plus minus 32 minus 0.5 alpha CB plus 18 J. So A is the acceleration of the particle. In this equation we are lack of AC and alpha CB. So we have one equation and two unknowns. So we can split this equation into the two equations. So the acceleration of the particle C is acting in this direction AC. So it has two components. So one component will be this and the second component will be this. So this will be equal to 3 by 5 AC and this will be 4 by 5 of AC. You can also find out by using by finding first angle using this triangle 3 4 5, and after that you can substitute the value of angle to find the components. So in this way the acceleration equation become, considering that this is x direction and this one is y direction. So it will be minus 4.5 ACI minus 3.5 ACJ. This will be the value of AC in vector form. So after that combining the items, after that equating the items in j term, we get the two equation. First equation we get minus 4 by 5 AC equal to 14.5 plus 2 alpha CB. The second equation we get is 3.5 AC equal to minus 14 minus 0.5 alpha CB. So after this you have two equations and two unknowns. So simultaneously by solving the equation simultaneously, you can get alpha CB equal to 12.4 radian per second and AC equal to 13 meter per square second. So this is the acceleration of the slider C and the angular velocity for the link BC. You can also write this acceleration equation in the vector form. So in vector form, AC equal to minus 4.5 times 13 I and minus 3 by 5 times 13 J in term of meter per square second. So this is the acceleration for the slider C.